Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to work out the practice problems from the arithmetic reasoning section of the second full-length practice test on my website. In case this is your first time finding my YouTube channel, I briefly want to mention that I created a small website called asvab-tutoring, and there you can take 3 short practice tests as well as 2 full-length practice tests. And all of those practice tests estimate your AFQT score. So if that's something you're interested in trying to figure out, go to that website and take those practice tests. In addition, I want to mention that YouTube has given me the ability to post exclusive content for channel members. So if you want access to that, consider supporting my channel by becoming a member. To do that, all you do is have to click the join button, which should be right next to the subscribe button on my homepage. As far as this video goes, I want to encourage you to make an effort to work out all these problems on your own. So one way you could do that is to go to the website and take this practice test. Otherwise, I recommend that you pause the video after I read each question, attempt to work out the question on your own, and then resume playing the video to check your solution. As a reminder, you're not permitted to use a calculator or a reference sheet on the ASVAB, so as you take this practice test either on my website or here on YouTube, make an effort not to use any of those resources. Finally, I want to mention that in the description of this video, I'm going to include timestamps that are associated with each question. Next to the timestamp, there's going to be the topic that the question's testing, as well as a link to a video in which I discuss that topic in greater detail. So if at any point you feel as if you need more help, just take a look in the description of this video, and there you'll find links to those videos for additional help. So all that being said, let's go ahead and get started with today's video. All right, so this first question says, a snowmobile, which is originally priced at $2,800, is on sale for 20% off. If the sales tax rate is 8.25%, what is its final sales price, including tax? So for this one, we have to do quite a few steps to figure out what the final sale price is going to be, including tax. The very first thing you have to do is calculate the sale price with no tax on it whatsoever. Okay, so that's what we're going to do first. After we calculate that amount, and I'm just going to call that SP for short, we're going to have to figure out what the sales price is plus tax. Okay, so again, when you calculate the sales price, you're not concerned about tax, but when you want to know the final sales price, you're going to include the tax amount. So let's go ahead and get started doing this. Again, you can find the sale price by following this. Again, sales price is always going to be the original price minus the discount amount times the original price. Okay, so in this case, we're trying to figure out what the sales price is. We know what the original price is. It's $2,800, so that's going to be $2,800. According to the problem, the discount amount is 20%, and on the ASVAB, you're always going to write percents as decimals, so that's the same as 0.2. So again, the discount amount is 20%, and we're going to multiply that by the original price. Okay, so let's work this off to the side so as not to make any mistakes. The very first thing I'm going to work off to the side is this 2,800 times 0.2. And as you can see, I'm multiplying a whole number, notably 2,800, by a decimal, notably 0.2. In order to make this math a little bit easier, I'm going to get rid of this decimal by shifting it one time to the right to make that just 2. So this becomes 2,800 times 2, albeit with one decimal to shift back into the left at the end when we're done. So we get 0 times 2, which is 0, 0 times 2, which is 0, 8 times 2, which is 16, so we're going to drop down a 6 and carry a 1, 2 times 2, which is 4, plus 1 is 5, bring that one decimal back over. So we can see that the sales price is going to be $2,800, which is the original price of the snowmobile, minus $560, which is the discount. Okay, and again, in an effort not to make any mistakes, I'm going to do 2,800 minus 560 off to the side. So we have 0 minus 0, which is 0. 0 minus 6 we can't do, so we're going to have to borrow. This is going to become 7. This is going to become 10. 10 minus 6 is 4. 7 minus 5 is 2. And we're just going to drop down this 2 since we're not subtracting it by anything. So the sales price, excluding tax, is $22.40. Okay? So we finished step 1. We found the sales price. Now we have to add tax to this sales price. And let's think about how we could do that algebraically. And let's do that over here. So to find the final sales price, which I'm going to call FSP, we're going to take the sales price and then we're going to add the tax amount times the sales price. Okay? And we have all this information. Again, this final sales price is going to be the sales price, which is this $22.40 over here, plus the tax amount. And let's go back to our problem to see what that was. Tax amount was 8.25%. Again, we're always going to use that in decimal form. So that's going to be 0.0825. So this is going to be 0.0825 times the sales price. So that's going to be $22.40. Okay, so let's go ahead and work this out, and we'll be done with this one. So again, over here we're doing 2240 times 0.0825. That is to say, let me make sure I got the right tax rate. Yep. That is to say we're multiplying a whole number by a decimal again. And to make this a little bit easier, I want to take this decimal and 0.0825 and shift it 1, 2, 3, 4 times to the right to get rid of that decimal completely. So this is going to become 2240 times 825, albeit with 4 decimals to move back into the left when we're done. Again, we moved them to the right here, and we'll move them back into the left when we're done. So let's do this math very quickly. We have 0 times 5, which is 0. 4 times 5, which is 20. So we're going to drop down to 0 and carry a 2. 5 times 2 is 10, plus 2 is 12. So we're going to drop down a 2 and carry a 1. 5 times 2 is 10, plus 1 is 11. Before we start multiplication with this 2, we have to add a 0 placeholder. Now this becomes 0 times 2, which is 0, 4 times 2, which is 8, 2 times 2, which is 4, and 2 times 2, which is 4. Okay, before we start multiplication with this 8, we have to bring in 2 0 placeholders, and this becomes 8 times 0, which is 0, 8 times 4, which is 32, so we're going to drop down a 2 and carry a 3. 2 times 8 is 16, 17, 18, 19. So we're going to carry a 1. 8 times 2 is 16, plus 1 is 17. Let's add this all up. We have 0 plus 0 plus 0, which is 0. 0 plus 0 plus 0, which is 0. 8 plus 2 is 10. So we're going to drop down a 0 and carry a 1. 4, 5, 6, 7, 8. 9 plus 5 is going to be 14. Carry a 1. 7 plus 1 is 8. And 1 plus nothing is 1. Let's bring our 4 decimal places back in. 1, 2, 3, 4. Okay, so we can see our tax amount, and we'll write it up over here. It's going to be 2240 plus 184.80, and we can just put 0.8. So now we just have to add these two together, and let's do that right here. We have 2240 plus 184.80, and we'll add a decimal here and a 0 there as needed. 0 plus 8 is 8. Drop down your decimal in place. 4 plus 0 is 4. 8 plus 4 is 8, 9, 10, 11, 12. Drop down a 2, carry a 1. 2 plus 1 is 3, plus 1 is 4. And 2 plus nothing is 2. So our final sales price, including taxes, $24.24.80, which is answer choice D in this case. Again, there's a lot of work in this problem, but none of it's too hard. And I recently created a video in which I showed you how to calculate a discount amount as well as tax. In this case, you had to do both of those things, which makes it a little more challenging than any problem in that video. So if you need to rewatch this video or go watch that other video, I'd recommend you do so. But this is a fairly simple problem that shows up somewhat frequently. So make sure you know how to do this one. All right, number 2 says if one piece of square tile is 12 inches long by 12 inches wide, how many pieces of tile will Mr. Smith need in total to cover a rectangular floor that is 11 feet wide by and 11 feet long? Okay, so we're dealing with two different shapes here. We have a square tile that's 12 by 12, and those are inches, of course. And then we have this big floor space that is 11 feet by 18 feet. Okay, the very first thing that you should notice is that whereas the dimensions of the tile are given in terms of inches, the dimensions of the floor space are given in terms of feet. So in order to do this one accurately, we're going to want to either convert these feet to inches or these inches to feet. And thankfully enough, it's very easy to convert these inches to feet because, as you should know, there are 12 inches in 1 foot. So this piece of tile is 1 foot by 1 foot. Okay? And we want to figure out how many of these pieces of tile will fit in this floor space. And that's actually pretty easy to do. We're going to take the area of the floor space, which I'm going to call area of the floor space. And that's pretty easy to figure out. Let me finish my thought here. We're going to take the area of the floor space and divide that by the area of one piece of tile. And by doing this division here, this will tell us how many pieces of tile we need to cover this entire floor space. So let's see how we can figure this out. Again, this floor space is a rectangle. So the area of rectangles is always given by length times width. And as I mentioned, this tile is a square. And to find the area of a square, that's side times side. So let's keep working this out. Again, the tile is 1 by 1 foot, so this is 1 by 1, whereas the length of this floor space is 18, and its width is 11. Okay, and let's keep working this out. 1 times 1 is just 1, and 18 by 11, I'm going to work off to the side. This is 18 times 11. 1 times 8 is 8. 1 times 1 is 1. Before we start multiplication with this 1, we have to bring in a 0 placeholder. 1 times 8 is 8. 1 times 1 is 1. Let's add these together. 8 plus nothing is 8. 8 plus 1 is 9. 1 plus nothing is 1. So this becomes 198 over 1. Anything divided by 1 is itself. So 198 divided by 1 is 198. In other words, it's going to take 198 pieces of 1 by 1 tile to cover a floor space that's 11 feet by 18 feet. So this one is 198, and that's that one. Not that difficult. A lot of people probably got stuck making this conversion from 12 inches to 1 foot. And then you had to be mindful of the fact that to find how many pieces you're going to need, you're going to take the area of the floor space and divide it by the area of a single piece of tile. Okay, so not too difficult. All right, number 3 says Sophie cast a 5-foot long shadow. If her father, who is 6 feet tall, cast an 8-foot long shadow, then how tall is Sophie? All right, so for this one, we're going to use a proportion to solve it. And the way I like to use proportions is like this. I like to fill in the left-hand side of the proportion with the information that I'm given, and then I'll put the information I'm trying to figure out in the right-hand side of the proportion. So according to this problem, we know the dad is 6 feet tall, and he cast an 8-foot shadow. So I'm going to put 6 feet tall here, and we'll do 8-foot shadow down there. And as I fill in the right-hand side of this proportion, I'm going to keep those things the same. I'm going to put height of the person in the numerator and length of the shadow in the denominator. So according to the problem, we know Sophie cast a 5-foot shadow. So this is going to be 5-foot shadow. And we want to know how tall she is. So in math, when you're trying to figure out an unknown, you can usually represent that with an x. So we'll call this x tall. All right, now that we've set up our proportion, all we have to use is some cross multiplication to figure this one out. First, I'm going to do 8 times x. 8 times x is the same as 8x. And then we're going to do 6 times 5. And I'm going to write that out just so you can see it. 6 times 5. Okay, so this is 8x equals 6 times 5, which is 30. To solve for x, which is the height of Sophie, we're going to divide both sides by 8. This will cross out here. This will become x equals, as we can see, 30 over 8. You can regard fractions in math as long division. So you can read this as 30 over 8 or 30 divided by 8, which is what we're going to do here. And let's work out this long division real quickly. 8 doesn't go into 3, so we're asking ourselves now, how many times does 8 go into 30? Well, 8 times 4 is 32, which is too big, so 8 goes into 33 times. 8 times 3 is 24. 30 minus 24 is 6. And again, for this problem, we're going to have to add a decimal and a 0 placeholder here, so we can drop down this 0 here. And once we add that decimal, we're going to bring it up right here. And the question becomes, how many times does 8 go into 60 without going over? Well, 8 times 8 is 64, whereas 8 times 7 is 56. So this is going to be 7. 8 times 7 is 56. And 60 minus 56 is 4. Again, we can add another 0 placeholder and bring it down. Now the question is, how many times does 8 go into 40? That's going to be 5 times. 8 times 5 is 40. 40 minus 40 is nothing. So we can see that x in this case is going to be 3.75. In other words, if we look back at our proportion here, we know this x refers to how tall Sophie is in terms of feet. So we know she's 3.75 feet tall. Unfortunately, our answer choices are given in terms of feet and inches. That said, we know she's 3.75 feet, so all these with a 4 are wrong. So by process of elimination, we know B is the correct answer. That said, let's say we wanted to convert this 0.75 feet into inches. Again, 0.75 is the same as 3/4, and inches are always over x, so we would do this math right here to figure out how many inches this is in terms of the conversion. So we would do 4 times x, which is 4x, equals 3 times 12, which is 36. Divide both sides by 4. This crosses out, and you can see x is 36 divided by 4 are 9. So 3.75 feet is the same as 3 feet and 9 inches. Okay, so that's that one. Not too difficult there, but that said, you have to be comfortable using proportions not only to set this problem up, but also to convert 0.75 feet to be in terms of inches. Okay, so that's that one. All right, number 4 says the length of a rectangle is 3 times its width. If the perimeter of the rectangle is 40 feet, then what is the area of the rectangle? So this is kind of a brain teaser problem, but that said, nothing is too difficult with this one. Let's start by making a diagram. Again, we know we're dealing with a rectangle, which is a pretty simple shape. And according to the problem, we know the length of the rectangle is 3 times its width. So if I let its width be x, that means its length is 3 times that, or 3x. In rectangles, we should know that if this side's x, this side's also going to be x, and likewise, if this length is 3x, that means this length over here is also going to be 3x. Okay? What's more, we're told the perimeter of this rectangle is 40 feet. So again, P usually denotes perimeter. We know P equals 40 feet. How can we use this information about this rectangle's perimeter as well as these x's to figure out what x is? Well, that's pretty easy to do. To find the perimeter of a rectangle, you add up all of the sides. So if you start at x, to find the perimeter, that would be x plus 3x plus x plus 3x. So let's go ahead and write that out. The perimeter of this rectangle would be x plus 3x plus x plus 3x. Okay? And what's more, the problem told us the perimeter is 40 feet. So in place of p here, I'm going to put 40. So again, this becomes 40 equals x plus 3x plus x plus 3x. Let's combine our like terms. This is 40 equals x plus 3x is 4x plus x is 5x plus 3x is 8x. Divide both sides by 8 to get x by itself. This crosses out here, leaving you with just x. 40 divided by 8, as we've seen in this video already, is going to be 5. Okay, so we know that, and let me draw this rectangle down here again. We know the width of the rectangle is x, which is 5. If x is 5, its length is 3x. 3 times 5 is 15. So we know we're dealing with a 5 by 15 rectangle. And again, as we just saw, to find the area of a rectangle, that's going to be length times width. So this is going to be 15 times 5. In case you can't do that in your head, let's work that off to the side. 15 times 5. 5 times 5 is 25. Carry a 2. 1 times 5 is 5 plus 2 is 7. So the area of this rectangle is 75 feet squared. Okay, so that's that one. A lot of basic math to figure this one out. But again, this is an example of a problem you may see on the ASVAB. You have to be comfortable saying, well, if this is x and this is 3 times as long, that means that's 3x. Okay? All right, number 5 says a car travels 50 miles an hour and a plane travels 10 miles a minute. How far will the car approximately travel when the plane travels 500 miles? So it should be obvious that we're dealing with distance, rate, and time for this problem. Again, distance, rate, and time are related, and more specifically, the distance formula shows you how those are related. Notably, distance equals rate times time. In this case, we have 2 instances of this relationship going on. So I'm going to write distance, rate, and time twice here. This one's going to be for the plane, and this one's going to be for the car. And according to this problem, we're going to use information that we're given about this plane to figure out how far this car travels. Okay? So let's read through this problem one more time to figure out what we have going on. We're told this plane travels 10 miles a minute. Well, believe it or not, that's a rate. Again, imagine if that said 10 miles per hour. You would say that's a rate. Well, 10 miles a minute is also a rate. It's just in terms of minutes. And likewise, we know the plane travels 500 miles, so that's our distance. Let's go ahead and plug those into the distance formula for this plane to figure out how long it takes to go those 500 miles. So this is distance, we know that's 500 miles. That's how far the plane travels. We know its rate is 10 miles a minute. And we want to figure out how long it's going to take that plane to go those 500 miles. So in this case, we're going to be solving for t. So let's divide both sides by 10 to get t by itself. This crosses out here, leaving you with t over there. We can cross out these corresponding zeros here. 50 divided by 1 is 50. And let's think about this. Our rate was given in terms of minutes. So our time here is also going to be in terms of minutes. So this says it takes the plane 50 minutes to go those 500 miles at a rate of 10 miles a minute. Okay? So let's use this information to figure out how far this car travels. Again, we're trying to figure out how far the car travels when the plane goes 500 miles. So the distance for this car is what we're trying to figure out. We know the car travels at a rate of 50 miles per hour, and we know that it's traveling for the same time that the plane traveled. Well, the plane over here traveled for 50 minutes, so this is going to be 50 minutes for our time over here. That said, we have a little bit of a problem here. We know the rate of the car is given in terms of hours, whereas this time's in terms of minutes. So we can't just plug in 50 here and get the correct answer. Instead, we have to rewrite this minutes to be in terms of hours. Of course, that's pretty easy to do. 50 minutes is the same as 50 over 60 of an hour. Again, there are 60 minutes in an hour. And if you cross out these corresponding zeros, you'll see that 50 minutes is the same as 5/6 of an hour. Okay, so now that we've rewritten this 50 minutes to be in terms of hours, notably 5/6 of an hour, we can go ahead and do this math. And this isn't too difficult to do. We have 50 over 1. Again, you can make any whole number a fraction by placing it over 1. So what we're going to do here is we're going to multiply straight across like this. That is to say, I'm going to do 50 times 5 over 1 times 6, which is just 6. Okay? Let's work this off to the side. 50 times 5. 5 times 0 is 0. 5 times 5 is 25. So this becomes distance equals 250 over 6. And I'm going to work this off to the side so as not to make any simple math mistakes. We're going to do 250, and my pen's starting to act up here a little bit, 250 divided by 6. And we're asking ourselves, how many times does 6 go into 25 without going over? It's going to be 4 times, given that 6 times 4 is 24. And right away, we know our answer for this distance is going to start with a 4. So if we wanted to, we can eliminate all these answer choices and be done right now. But that said, let's keep working this one out. 25 minus 24 is 1. Drop down this 0. Now we're asking ourselves, how many times does 6 go into 10? 6 goes into 10 one time without going over, given that 1 times 6 is 6. 10 minus 6 is 4. And now we're going to add a decimal and a 0 placeholder. As soon as we add that decimal, we're going to bring it up here and drop down this 0 placeholder. And the question becomes, how many times does 6 go into 40 without going over? That's going to be 6 times, given that 6 times 6 is 36. 40 minus 36 is 4, and we're going to add another 0 placeholder, which we can drop down. And as you can see, this fraction is going to repeat like this over and over again. So in this case, they took this 41.666, repeat it, and they just rounded it up to be 41.7 miles. So approximately, this car will go 41.7 miles when this plane goes 500 miles. So the answer to this one is, in fact, C. Kind of tricky, but nothing too difficult. Again, this is the last practice test I'm putting on that website, and so I had to make it more challenging than the other ones have been so far. So again, you should have been able to work that out. If not, you see it now, and you should still be able to work it out if you see it on test day. All right, let me get my pen back. All right, number 6 says Farmer Jones owns a citrus tree farm in Florida. During some parts of the year, the amount of rain in Florida is not sufficient enough to maintain the maximum growth of his citrus trees. Because of this, Farmer Jones decided to buy a water tank. How much water will his tank hold if it's a right circular cylinder with a height of 10 feet and a radius of 5 feet? Okay, so believe it or not, this is a pretty simple problem. We're dealing with a cylinder here, which kind of looks like this, has a circular top and a circular base. And we're told what the dimensions of it are. It's 10 feet tall, so it has a height of 10 feet. And it has a radius, which is the distance from the center point of the circle to the edge of the circle of 5 feet. And we want to know how much water will his tank hold. In other words, we want to know the volume of this circular cylinder. Well, this is actually very, very easy to figure out. Again, what you're going to do is you're going to find the area of this circular face, and area of circles is always pi r squared. Then you're just going to multiply it by the height of this cylinder. So just like that, we came up with the formula to find the volume of the cylinder. So all we do is have to plug these values in and perform the arithmetic accordingly. Get on the ASVAB, you're always going to let pi be 3.14 unless the test specifies otherwise, and sometimes it will. So be careful about that. So we have pi. The radius, according to the problem, was 5, so this is 5 squared. The height was 10. Okay, so let's keep working this out. 5 squared is 25 times 10. 25 times 10 should be pretty easy to do in your head. Again, you're multiplying 25 by a power of 10, notably 10. So you're going to take the decimal in 25, which is right here, and shift it to the right according to how many zeros there are in the power of 10. In 10, there's 1 0, so we're going to shift this decimal one time, and we're going to add a 0 placeholder. So this becomes 250 pi. And if we look at our answer choices, we can see that we have to work that out, which is no big deal. We'll do it off to the side. This becomes 3.14, which is an approximation of pi, times 250. Since we're multiplying a decimal by a whole number, we're going to shift its decimal 2 times to the right to make 3.14 314. Again, this is times 250. And once we get done working this out, we'll shift those 2 decimals back into the left. So we have 4 times 0, which is 0, 1 times 0, which is 0, 3 times 0, which is 0. Before we start multiplication with this 5, which is the second term, we have to bring in a 0 placeholder. 5 times 4 is 20, so bring down a 0, carry a 2. 5 times 1 is 5, plus 2 is 7. 3 times 5 is 15. Before we start multiplication with this third term, we have to bring in 2 0 placeholders. 2 times 4 is 8. 2 times 1 is 2. And 2 times 3 is 6. Let's add this all up. 0 plus 0 plus 0 is 0. 0 plus 0 plus 0 is 0. 7 plus 8 is going to be 15, so we're going to carry a 1. 5 plus 2 is 7, plus 1 is 8. And 6 plus 1 is 7. Bring our 2 decimals back in. So we can see the volume of water that this tank holds is 785. And this was given in feet, so this is feet cubed. Okay? So again, volume is always cubed. Area and surface area is always squared. So this one is 785 cubed, which we can see is D. Okay, so nothing too tricky about that. You just had to remember the formula to find the area of a right circular cylinder. Again, I would recommend you memorize this one for the ASVAB. You may or may not see it, but it's good to know. It's not that hard to figure out either. All right, number 7 says, if a circular racetrack has a diameter of a ½ mile, how far does a car travel in 1 lap around the track? Okay, so now we're dealing with a circular racetrack that has a diameter of a half a mile. And in case you forgot, diameter is defined as the distance from one edge of the circle to the other edge of the circle and through the center point of the circle. So that distance right here is the diameter, and according to the problem, it's half a mile. Okay? And we want to figure out how far does a car travel in one lap around the track. So in other words, we want to figure out what the circumference of this circular track is, and that's always going to be circumference equals pi times diameter. So this becomes pi times 1/2. And I like dealing with decimals, so I'm going to call this 0.5 pi. Again, 0.5 is the same as 1/2. Of course, since it's not specified, we're going to let pi be 3.14. So this becomes 0.5 times 3.14. And let's go ahead and work that out. We have 3.14 times 0.5. Again, we're multiplying two decimals now, notably 3.14 and 0.5. So we're going to shift the decimal and 3.14 two times to the right to make that 314. And we're going to shift the decimal in, my pen's starting to act up here a little bit, one time to the right to make that just 5. In total, we shifted the decimal place 2 plus 1 times, so 3 times. Once I work this out, I'm going to shift the decimal back to the left 3 times to make up for the fact I moved it to the right here 3 times. 4 times 5 is 20, so we're going to bring down a 0 and carry a 2. 1 times 5 is 5, plus 2 is 7, and 3 times 5 is 15. Bring our 3 decimals back in, 1, 2, 3. So the circumference is 1.57 miles. In other words, every lap of this track, the car will go 1.57 miles, which is answer choice C. Okay, so that's that one. All right, number 8 says the number of people attending a weekly training program in the month of January averaged 116 people. If there were 105 people attending the first week, 106 people the second, and 105 the third, how many people attended the fourth week? So this is an average problem in which we have to solve for one of the missing data points. So again, to find the average of anything, you always find the sum of all the data points divided by how many data points there are. In this case, we're told what the average of January was. That was 116. So in place of this average, we're going to put 116. Likewise, we're told the first week of January, 105 people attended. The second week, 106 people attended. And the third week, 125 people attended. And we want to figure out how many people attended the fourth week in January. Again, in a month, there are 4 weeks. And since that's unknown, we can call that X. Again, average is the sum of the data points, which we just wrote out, including the unknown one, divided by how many data points there are. There are 1, 2, 3, 4. So all we have to do is solve this equation for X, and we'll have our answer here. So the very first thing I'm going to do is multiply both sides by 4. This crosses out over here, leaving you with this. 105 plus 106 plus 125 plus X equals 116 times 4. And so as not to make any mistakes, I'm going to work that off to the side right here. So 116 times 4. 6 times 4 is 24, so we're going to bring down a 4 and carry a 2. 1 times 4 is 4, plus 2 is 6, and 4 times 1 is 4. So this is 464. To get X by itself, I have to move all these values over to the left. But prior to moving them one by one, I'm just going to combine them. So let's do that next. This is 105, 106, and 125. 5 plus 5 is 10, plus 6 is 16. So we're going to drop down a 6 and carry a 1. 1 plus 2 is 3. 1 plus 1 plus 1 is 3. So this is this right here is 336, so this becomes 336 plus x equals 464. To get x by itself now, we're going to subtract 336 from both sides. This crosses out here, leaving you with just x. As we can see, x is 464 minus 336. So this is 464 minus 336. 4 minus 6 we can't do, so we have to borrow. This becomes 5. This becomes 14. 14 minus 6 is 8. 5 minus 3 is 2. And 4 minus 3 is 1. So we can see x is 128. And in math, you usually write the variable for which you solved on the left. So this is x equals 128. In other words, in the 4th week of January, 128 people must have attended this conference in order for the average to have been 116. So the answer to this one is 128B. All right, number 9 says a butcher makes 22.5 pounds of beef into hamburger and wrapped it into 1 1/4 pound packages. How many packages of hamburger did he make in total? So this one is going to be pretty easy. We're just going to take 22 and 1/2, and we're going to divide that by 1 1/4. Again, he has 22.5 pounds of beef that he's making into 1 1/4 pound packages. Okay, so we're going to do division here. That said, we're doing division with mixed numbers, which isn't necessarily that easy to do. So the very first thing I'm going to do is I'm going to convert these mixed numbers to improper fractions. And to do that, we're going to do this. Let's start in the denominator. We're going to do 1 times 4, which is 4, plus 1, which is 5. So this is the same as 5 over 4. We're going to do the same thing here. This is 22 times 2 plus 1. Well, 22 times 2 is going to be 44 plus 1 is 45. So this is the same as 45 over 2. Now that we're dividing two fractions, or two improper fractions more specifically, we can follow the algorithm keep, change, flip. Again, this keep refers to this first fraction right here. We're going to keep it the same. So this is going to be 45 over 2. This C refers to change, and it refers to the division sign right here. We're going to change it from division to multiplication. And this F means flip, and it refers to the second fraction. And instead of being 5 over 4, it's going to be 4 over 5. Okay? And now that we've done that, we're just going to multiply straight across. But that said, I want to reduce this before I multiply straight across. Again, I know 5 and 45 share a common factor of 5. Again, 5 goes into 5 one time. 5 goes into 45 9 times. Okay, so this makes the math a little bit easier. Let's go ahead and work this out now. Again, this is 9 times 4. 9 times 4 is 36, of course. And this should be a 1 here. I don't know why I wrote 5 over 2 times 1, which is just 2. So this becomes 36 divided by 2. If you can't work that out mentally, you can always work it off to the side like this. 2 goes into 3 one time without going over. 2 times 1 is 2. 3 minus 2 is 1. And we drop down this 6. 2 goes into 16 8 times without going over. 2 times 8 is 16. We can see there's no remainder. So the answer to this one is 18. And that 18, of course, refers to the number of packages he can make from this 22.5 pounds of beef. So the answer is A. Okay, just a test of your ability to work with fractions there. All right, so number 10 says the area of a circle is 4 times bigger than a smaller circle that has a radius of 3 inches. What is the radius of the larger circle? So in this case, we're comparing two circles. We have one small circle here and another big circle here. Okay? And we're told, what's more, that the area of this big circle is 4 times that of this smaller circle, okay? So again, we're working with the area of a circle, which is the formula pi r squared. Let's find the area of this small circle to start. We know it has a radius of 3 inches. And again, radius is the distance from the center point to the edge. So the area of this small circle is going to be, again, it's pi r squared. The radius in this case is 3 squared. So that's going to be 9 pi. Okay. So we know the area of this big circle is 4 times the area of this smaller circle. So if this smaller circle has an area of 9 pi, this is going to be area equals 4 times 9 pi. 9 times 4 is 36. So the area of this bigger circle is 36 pi. Okay? We want to know the radius of this larger circle. So we have to think about how we're going to figure out what this radius is. Well, it's not that difficult to do. We know the area of this larger circle, and we can plug that into this area formula over here and solve for r. So let's see what that looks like. Again, the area of this larger circle is 36 pi. So this is 36 pi equals pi r squared. Again, we're solving for its radius. We want to know what that's going to be. So the very first thing I'm going to do is divide both sides by pi. This crosses out, leaving you with r squared over here. This crosses out over here, leaving you with just 36. Again, to find the radius, or just r, not r squared, we're going to take the square root of both sides. This crosses out this square over here, just leaving you with r. Square root of 36 is 6. So this radius right here is 6. So the answer to this one is 6 inches. All right, so kind of a tough problem, but nothing too difficult. Again, you just had to use some logic. And now that you've seen it, if you see a question like this on the ASVAB, you'll absolutely know how to attack it. Okay, so that's that one. All right, number 11 says a class of 198 Army Ranger recruits are from Georgia, North Carolina, and South Carolina, respectively. If 1/3 of the recruits are from Georgia and 1/4 of the remaining recruits are from North Carolina, then how many of the recruits are from South Carolina? So for this one, I'm going to draw a circle graph to illustrate what's going on. So in total, we know we have this class of 198 recruits. And we're told that 1/3 of them are from Georgia. So right away, we know about 1/3 of them are from Georgia. Okay. Let's figure out what that amount is. And that's not that hard to do. Again, we'll take 198 and multiply it by 1/3. And this will tell us how many recruits are from Georgia. Okay. And again, we're multiplying a whole number by a fraction. So we're going to go ahead and place this over 1 and then multiply straight across. This becomes 198 times 1, which is 198, over 3 times 1, which is 3. All right, so let's go ahead and work this out. A quick way to test if a number is divisible by 3 is to sum all the numbers. So 1 plus 9 is 10, plus 8 is 18. 18 divided by 3 is 6. So since 18 divides by 3 evenly, I know 198 is also going to divide by 3 evenly. So this is going to be 198 divided by 3. 3 goes into 9. 19 6 times without going over. 3 times 6 is 18. 19 minus 18 is 1. Drop down this 8. 3 goes into 18 6 times. Again, 3 times 6 is 18, so there's no remainder here. So if 1/3 of the recruits are from Georgia, we know that 66 of them are from Georgia. Okay? According to the problem, we know 1/4 of the remaining recruits are from North Carolina. Okay? So Again, let's disregard this big circle and let's just make a smaller circle that's just in regard to North Carolina and South Carolina. Again, according to the problem, 1/4 of the remaining recruits are from North Carolina, which means 3/4 of the other recruits are from South Carolina. Okay? We have to figure out how many of the recruits this is. So we're going to take 198, which is the total number of recruits, and subtract 66 from it, which is how many recruits are from Georgia. So this is 8 minus 6, which is 2, 9 minus 6 is 3, and 1 minus nothing is 1. So this is 132. Again, we want to figure out how many of the recruits are from South Carolina in this case. So we're going to find what 3/4 of 132 is. So this becomes 132 times 3/4. Again, we can place this over 1. And let's go ahead and work this out. Again, we have 132 times 3 divided by 4. Again, 1 times 4 is 4. Let's work this out. We have 132 times 3. That's 2 times 3, which is 6. 3 times 3, which is 9. 1 times 3, which is 3. So this is 396 divided by 4. Let's go ahead and do this division now. 396 divided by 4. 4 goes into 39 9 times without going over. Given that 4 times 9 is 36. 39 minus 36 is 6. Drop down to 6. 4 goes into 36 9 times evenly. Given that 4 times 9 is 36. So we can see there's no remainder. All right, so the number of recruits from South Carolina, as we just figured out, is 99. And that is the answer to this one. It's going to be 99. Got a lot of steps to this one, but nothing too difficult. All right, number 12 says, if a PlayStation 5 was bought for $558 after a 10% discount, what was the original price of the PlayStation 5? So for this one, we have to know how to figure out the original price given the sales price. And again, we're going to use this formula. Again, sales price is always the original price minus the discount amount, which is 10% in this case, times the original price. Okay? As I mentioned, percents are always going to be expressed in decimal form, so this is going to be 0.1, and we know the sales price was $558. So let's plug those things in and see what we have left. We have sales price, that's $558. The original price is what we're trying to figure out, so I'm going to call that X minus the discount amount, which is in decimal form 0.1, times the original price, which again I'm going to call X. Okay, so this one becomes 558 equals, and again, if it's not obvious, there's a 1 here. This is the same as 1x minus 0.1x. And let me work this off to the side. This is 1 minus 0.1. Okay? 0 minus 0 is 0. 1 minus 0 we can't do, so we have to borrow. This becomes 0. This becomes 10. 10 minus 1 is 9. Drop down your decimal. And 0 minus nothing is 0. So this becomes 0.9x. Now we're just going to divide both sides by 0.9 to get x by itself. This crosses out here, leaving you with just x over there. And as you can see, x equals 558 divided by 0.9, which I'm going to work off to the side here. Again, this is 558 divided by 0.9. Now we're doing long division, in which the decimal's outside the division bracket. In order to proceed, I'm going to shift this decimal 1 time to the right to make that 9. And at the same time, I'm going to have to take the decimal in 558 and shift it 1 time to the right as well and add a 0 placeholder. Again, this is to keep proportionality. So this is 5580 divided by 9. Let's go ahead and work this out. How many times does 9 go into 55 without going over? Well, 9 times 7 is 63. 9 times 6 is 54. So this is going to be 6 times. 9 times 6 is 54. 55 minus 54 is 1. And now we drop down this 8. And we can also drop down this 0 because this is pretty easy to do. How many times does 9 go into 18? That's 2 times. How many times does 9 go into 180? That's going to be 20 times. So 9 times 20 is 180 with no remainder. And as we can see, x is 620. In math, it's customary to write the variable for which you solved on the left. So this is x equals 620. And this x, as you saw, referred to the original price of this PlayStation. So the original price of this PlayStation before the discount was applied was $620. So that's that one. Again, I have a video on this in case you need to review how to do this. But again, you should be able to set this one up algebraically by saying sales price is always the original price minus the discount amount times the original price. Okay, so that's that one. Let me go ahead and get rid of this marker here so we can see this next problem. All right, number 13 says Robin can paint a room in 4 hours, whereas Susan can paint the same room in 7 hours. How long will it take them to paint the room if they work together? So this is what's called a combined rate problem, and I do have a video on that. In that video, I mentioned that you should be familiar with a generic formula that you can use to solve combined rate problems. That is T over A plus T over B equals 1, where T refers to the amount of time it takes the people working together to complete one task. A refers to the time it takes one person to complete the task by themselves, and B refers to the time it takes the other person, to complete the task by themselves. So Robin can paint the room in 4 hours by herself. We're going to call that A. Susan can paint the room in 7 hours by herself. We're going to call that B. Okay, so let's plug those in respectively. We have T over, again, Robin can paint the room in 4 hours by herself, plus T over Susan can paint the room in 7 hours by herself. And again, they can paint one room together. So by solving for T, we'll figure out how long it's going to take them to paint the room working together. That said, you can see we're adding two fractions here. And in order to add fractions, they have to have the same denominators. So we're going to have to rewrite these fractions such that they have the same denominators. The easiest way to do that is to take 4 and multiply it by 7 and make that your denominator. 4 times 7 is 28. So we're going to let that be our new denominator down here. To make 4 28, we multiply it by 7. Again, 4 times 7 is 28. We're also going to have to do that to the numerator. So 7 times t is 7t. Likewise, to make 7 28, we have to multiply it by 4. And we're also going to do that to the numerator. 7 times 4 is 28. 4 times t is 4t. Of course, this equals 1. All right, so now we're just adding fractions, and we're just going to combine their numerator. So this becomes 7t plus 4t over 28 equals 1. And I'm going to block this off since we're starting to work over here now. 7 plus 4 is 7, 8, 9, 10, 11. This says 11t over 28 equals 1. Again, we're trying to solve for t at this point, so I'm going to multiply both sides by 28 to clear it from the denominator. This crosses out here, leaving you with the, I don't know why I wrote pi there, 11t equals 1 times 28, which is 28. Again, divide both sides by 11 to get t by itself. This crosses out here, leaving you with t over there. And as we can see, t is 28 divided by 11. So let's work this out. How many times does how many times does 11 go into 28 without going over? It's going to be 2 times. 11 times 2 is 22. 28 minus 22 is going to be 6. And of course, now we can add a decimal place and a 0 placeholder, which will enable us to drop down this 0 and bring this decimal up here. How many times does 11 go into 60 without going over? That's going to be 5 times. 11 times 5 is 55. 60 minus 55 is going to be 5. And again, we have a 0 placeholder we can drop down now. And the question is, how many times does 11 go into 50 without going over? Well, that's going to be 4 times. 11 times 4 is 44. And I think we have enough to answer this question. It said, how much time will it take them to paint the room if they work together? Again, this is 2.54 hours, and they just rounded it down to be 2.5 hours. So this one is going to be C, 2.5 hours. So that's that one. All right, number 14 says the height of a triangle is 4 inches more than twice the length of the base. If the area of the triangle is 35 square inches, what is the height of the triangle? So we're working with a triangle, and it didn't specify what type. So I'm just going to make this a nice right triangle. Okay? And let's label this according to what the problem told us. Again, this is going to be the height. This is going to be our base. We know the area of a triangle. My pen's starting to act up here. The area of a triangle is 1/2 base times height. Okay? According to the problem, the height of the triangle is 4 inches more than twice the length of the base. So if I call the base x, that means the height is 4 inches more than twice the length of the base. So that would be 2x plus 4. Okay? And what's more, we know the area of this triangle is 35 inches, or 35 square inches, and we want to figure out what the height is. So let's see how we're going to do this. Again, we're going to plug in things into the area formula to figure out what the height is. And again, we know area is 35, so this is going to become 35 equals 1/2. The base I called x, so this is x. And the height I called 2x plus 4. I don't know why my pen's acting up here, but it is. So let's work this out. The very first thing I'm going to do is take this x and distribute it here and here. So this becomes 35 equals 1/2 times x times 2x is 2x squared, and then x times 4 is plus 4x. Okay? All right, and again, we got to deal with this 1/2, and we can just distribute that now to here and here. This becomes 1/2 times 2x squared. That's just going to be x squared. 1/2 times 4x is just 2x. Of course, this equals 35. So if we look at our base and our height, we should see that if we figure out what x is, we can plug that in and find the height of this. And that said, we got this, so far we got this quadratic looking thing here. Let's move this 35 over here. And let's see what we have now. We have x squared plus 2x minus 35 equals 0. Well, this is a quadratic equation, and as you may recall, we can factor these to solve for x. Let me fix that real quick. So now, if we're factoring this to solve for x, we're looking for two terms that multiply to negative 35 but add to positive 2. Well, how about plus 7 and minus 5? Again, 7 times negative 5 is negative 35. Plus 7 minus 5 is positive 2. Okay? Now we're going to break these two apart and set them equal to 0 separately. So this is x plus 7 equals 0. X minus 5 equals 0. If we're solving for x, we're going to subtract 7 from both sides here, and my pen is starting to die on me here. Just bear with me. This crosses out here, leaving you with x equals 0 minus 7, which is negative 7. And let's add 5 to both sides over here to get x by itself. This crosses out, and this says x equals 0 plus 5, or just 5. Again, we're talking about the length and base, or the height and base of a shape. So it can't be negative. So we know x is going to be positive 5. And we want to know more specifically the height of this triangle. Well, we know x equals 5. So let's just plug that in place of x here. This becomes 2 times 5 plus 4. 2 times 5 is 10 plus 4. 10 plus 4 is 14. So the answer to this one is C, 14 inches. Okay, so again, you had to use some factoring over here to solve for x. And then once you found x, you could plug it in and find the height. Pretty difficult problem. If you're going to score somewhere between 75 and 99, they might get this difficult, but it's still good to see a problem like this because, again, everyone wants to score as high as possible. So that's a good question there. All right, number 15 says a vegetable garden is 30 feet by 40 feet. A fence is built around the garden at a cost of $1.75 per foot of fencing. What is the total cost of fencing? Okay, so we're dealing with a vegetable garden that has a rectangular shape. More specifically, it's 30 feet wide by 40 feet long. And as far as rectangles go, we should know that if this side's 40, that means this side's also 40. And if this side's 30, this side's also going to be 30. And we want to know how much it's going to cost to enclose this garden with a fence. So in other words, we want to know what the perimeter of this garden is. Well, as we've seen in this video already, to find the perimeter, you just add up all the sides. So this becomes 30 plus 40 plus 30 plus 40. And let's go ahead and add those up. It's not that hard to do this one mentally. 40 and 40 is 80. 30 and 30 is 60. Again, 6 plus 8 would be 14. Therefore, 60 plus 80 is going to be 140. So it's going to take 140, and my pen is really starting to act up now. It's going to take 140 feet of fencing to enclose this one, this garden. So this is going to be 140 times the cost of fencing per foot, which is going to be 1.75 per foot. As you can see, we're multiplying a whole number by a decimal. To make this math a little bit easier, we're going to shift the decimal in 1.75 2 times to the right, and this becomes 175 times 140, albeit with 2 decimals to move back into the left at the end when we're done. So let's work this out. 5 times 0 is 0. 7 times 0 is 0. 1 times 0 is 0. Before we start multiplication with this 4, we have to bring in 1 0 placeholder. 5 times 4 is 20, so we're going to bring down a 0 and carry a 2. 7 times 4 is 28, 29, 30, so we're going to bring down a 0 and carry a 3. 1 times 4 is 4 plus 3 is 7. And before we start multiplication with this 1 now, we have to bring in 2 0 placeholders. 1 times 5 is 5. 1 times 7 is 7. 1 times 1 is 1. Let's add this all up. 0 plus 0 plus 0 is 0. 0 plus 0 plus 0 is 0. 5 plus 0 plus 0 is 5. 7 plus 7 is 14. Carry a 1. 1 plus 1 is 2. Bring in our 2 decimals. So we can see that it's going to cost $245 to enclose this vegetable garden with fencing if it cost $1.75 per foot of fencing. So the answer to this one is A. Okay, so that's that one. All right, number 16, which is probably the hardest question in this video, says if a boat can travel 16 miles against the current of a river in 2 hours and 36 miles with the help of a current in 3 hours, then what is the speed of the boat in still water? Okay, so for this one, I'm going to make a little illustration to try to depict what's going on here. We have this boat, and I'm just going to draw a square since I'm not very artistic. It goes against the current in this first instance. So let me just draw the current going against it. And according to the problem, it takes it 2 hours in this instance to go 16 miles. Okay? Likewise, we're told if the boat travels with the current, so here's my boat. It's now going with the current, so the current's actually pushing the boat to speed up its rate. We're told that it can go 36 miles in 3 hours, okay? And we want to know what the rate of the boat is in still water. So in other words, we have to figure out how to represent this current in as much as it's affecting the rate of the speed of the boat. So again, we're working with the distance formula here. Distance equals rate times time. That said, our rate is being affected by the speed of the current. In this case, the current is working against the boat. So it's actually slowing down or subtracting speed away from the boat. So I'm going to call this R minus C, where R refers to the rate of the speed of the boat and C refers to the current. In this instance down here, we know that the boat's going with the current. So the current is increasing the rate of the speed of the boat. It's helping it go faster. So that's going to be R plus C. All right, so let's use 2 instances of the distance formula to set up a system of equations to solve this one. So again, we're working with distance equals rate times time. So for this first one, we know that the distance is going to be 16 miles. Again, that's given. It takes the boat 2 hours to go 16 miles, and its rate is right here. So this is R minus C, and again, we're told it takes 2 hours to go that 16 miles. Likewise, this is the second instance where the boat's being helped by the current. We know it goes 36 miles, and the current is speeding it up. So our rate in the distance formula is R plus C, and we know it took 3 hours for it to go this distance. So the very next thing I want to do is take this 2 and distribute it here and here, and this 3 and distribute it to this R and C as well. So let's do that. This becomes 16 equals 2 times R is 2R. 2 times negative C is negative 2C. And likewise, this becomes 36 equals 3 times R, which is 3R, 3 times C, which is plus 3C. Let's get rid of these 2's and 3's. I could divide everything by 2 here, and my pen's starting to die on me, to get rid of the 2's in all this problem. And likewise, I can divide everything by 3 to get rid of the 3's here. Again, this becomes 16 divided by 2, which is 8, equals, again, this is just going to cross out here, R, and this crosses out here, minus C. And 36 divided by 3 is going to be 12, equals, again, this crosses out here and this crosses out here. So this is R plus C. Again, R refers to the rate of the speed of the boat, the rate of the boat in still water. So we just want to solve for R at this point. And we have a little system of equations here. If we just add these 2 together, we can see that this C variable, this current variable, drops out. So let's do that. 8 plus 12 is 20. R plus R is 2R. Negative C plus positive C is eliminated. Okay, so let's divide both sides by 2 now to get R by itself. This crosses out here, leaving you with just R. 20 divided by 2 is 10. Again, this R refers to the speed of the boat without the current affecting it, so it's the speed of the boat in still water. And we can see that is 10 miles per hour, which is B. Okay, so that's this one, and that is it for this practice test. I will say this. If I were to put this practice test on a scale of 1 to 10, this is definitely a 10 out of 10. And I did that because, again, on my website, the practice tests go from being very easy to very challenging. So if you take those 5 practice tests, you'll see a wide array of different types of problems, which will prepare you very well for the ASVAB. So again, don't worry if this was pretty challenging. By design, it was supposed to be challenging. Okay. Again, if you want to support my channel, please consider becoming a channel member. Even if you don't, I'm still going to be posting a lot of free content on my YouTube channel. Regardless of everything else, I hope you found this video helpful. As always, you're more than welcome to leave feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.